In the last video, we have seen how to create the data frames using the lists, using the dictionaries or the NumPy arrays. Now I hope you understand what the data frame is, how it helps us to create the two-dimensional grid of data. And in addition, we have seen an interesting thing, so how to load the data from the data that is available in the Excel file. That's what we have discussed in the last video. So now let's see how we can access the data from the data frame. That is how to access a specific row, specific column or range of rows, range of columns. So how do we access the data? We'll see now. So you can use the method head, which allows you to view the top 5 rows of the data frame. So here I am using data frame 4 for your illustrations. So I am using data frame 4, DF4 data frame for the illustrations. So to load the first 5 rows of the data frame, we can use the method head. So if you do not pass any argument to this head method, by default it retrieves the first 5 rows. So if you would like to specify the number of rows, that is also possible. Say for example, I would like to read the first 10 rows from the data frame. So it retrieves all the rows from 0th to 9th, the indexed with 0 to 9. That is how you can access the rows from the beginning of the data frame. So now let's see how we can access the rows from the end of the data frame. So to support that, we have the tail method. So tail method allows us to retrieve the rows from the end of the data frame. So here you can observe from DF4, we are retrieving the rows from the end. Here you can observe the indices 68, 69, 70, 71, 72. So there are a total of 73 rows in the DF4. So from the bottom, we are able to retrieve the last 5 rows. So to mention the number of rows you would like to visit, so you can do that also. So say for example, you would like to retrieve only 3 rows from the end. So now you can see 70, 71 and 72. Those 3 last rows are retrieved by passing the value 3 to the tail method. Now how do you retrieve a particular column? So columns also can be retrieved in multiple ways. One way to retrieve the column is just by passing its name. So if you observe here, register number is the name of this column. To retrieve this column, so we can pass the column name as a key value so that column is retrieved. So you can observe here, so the first column of DF4 is retrieved. If you would like to retrieve data from multiple columns, then you need to pass the names of those columns as a list. So if you observe here, so I would like to retrieve register number and name. Both the columns I would like to retrieve. So I am passing both their column names separated by comma as a list. So you need to understand that. So you should enclose it as a list to the indexing operator, so that it retrieves both register number and name. Now how do we access specific rows? So we have seen how to use the head and the tail methods to access the rows from the beginning or end, right? So instead of that, is it possible to access any specific row? So I want to access the 25th row from the data frame. Then, so you can pass 25:26, so that it retrieves the 25th column. Say for example, I would like to access a range of rows. So how can I access? You know very well, right? So you need to use the range operator. So you can use the range operator to access any specific range of rows from the data frame. So DF4 of 10 to 15. So it retrieves all the rows whose indices are 10, 11, 12, 13, 14. So you need to remember 15 is not included, it is excluded, because in the slicing operator always the end value is excluded. So far we have seen how to access a specific row, specific column, range of rows and multiple columns, how to retrieve we have seen, and the intersection of rows and columns, how do we access that? So say for example, I would like to access from 4th row to 69th row. So all these details I would like to access, and especially I would like to retrieve the column details of name and pending backlogs alone. So the intersection of rows and columns, how do we retrieve that? So to serve this purpose, so we have the LOC and the ILOC attributes. We can retrieve the intersection of rows and columns in the data frame by using the LOC or the ILOC attributes. So both these LOC and ILOC takes 2 arguments, where the first argument indicates the row details and the second argument indicates the column details. But in case of the LOC, so the second argument, that is the column details, must be passed as names. In case of the ILOC, the column details can be passed as index values. Here I stands for integer, that is integer location it expects for the column details. So that is how you can use the LOC and ILOC to retrieve the intersection of rows and columns. Now let's see some examples. So here in this case I would like to, so now let's have a look at this DF4. So DF4 is a data frame which contains set of columns with the names, register number, name, pending backlogs, aggregate credit, so on and so forth. and it's having total of 73 rows. So it's having total of 73 rows and 7 columns, right? So from this I would like to retrieve specific columns, and I would like to retrieve all the rows. Colon here to indicate all the rows, and in the rows I would like to retrieve only register number and name. So I don't want to retrieve all the columns. I want to retrieve only the register number and name. So I need to pass those details as a list. So here you can observe, so all the names of the columns separated by comma is passed as a list in the column details as second argument to this LOC attribute, so that I get the details of register number and name for all the students. So now let's see how we can retrieve the register number and name for few students. So say for example, I would like to retrieve the details from 10th student to 15th student in the list. Only the register number and name of the students I would like to retrieve. So I can pass 10:15 as the first argument and the names of the columns as a second argument. So in this case we have seen how to get all the rows and few columns, right? Say for example, I would like to retrieve few rows with all the columns. So in that case, what I need to do is I can pass colon as the second argument for this LOC, and so whichever rows you would like to pass, that range as the first argument. So 10:15, it retrieves the rows which are indexed with 10 to 15 are retrieved, and all the columns as we are passing colon as the second argument. So that is how the LOC attribute can be used to retrieve the intersection of rows and columns in a data frame. So now let's see how we can use the ILOC attribute, which accepts the integer indexing for columns. That is, the first column is indexed as 0, so you can assume that, and this is the column indexed as 1, 2, so on and so forth. That is how we need to assume that every column is integer indexed. So in the case of the ILOC attribute, you need to pass only the integer indexing. Say for example, I would like to access the name, so then the aggregate and the hostler details. So how do I do that? So 0, 1. So this is the first column, the name column I would like to access, then the pending backlogs. So that is the second column, and the fifth column 0, 1, 2, 3, 4, 5. So hostler or not, that information. So 1, 2, 5, I am passing only the integer index values for the columns, and I would like to retrieve all the rows, only few columns with all the rows, so that I can use this colon symbol in place of the rows. So instead we can get specific rows also, say for example from 16 to 26 all the rows, so with only those column details. So this is how we can mention the range of the rows also. So maybe we can put a restriction on the rows, and so I would like to retrieve all the columns. So that is also possible with this iLocation by passing colon in place of the columns. So that is how we can get the intersection of rows and columns from a given data frame. So far in this lecture we have seen how to access the elements, that is how to access specific rows, specific columns, even the intersection of the rows and columns. So how to retrieve. So all those details we have seen in detail with various examples. So in the next class we'll see some more operations on this data frames. Thank you for watching this video.